National Electrical Code Article 430 covers motors, motor circuits, and controllers. Section 430.110 addresses motor circuit disconnecting means, stating that the disconnecting means for motor circuit shall be capable of firstly interrupting the total current under normal operating conditions and secondly interrupting the current in excess of that specified in 430.22a. Furthermore, the disconnecting means shall be capable of being locked in the open position and located at the point of motor control. However, there are exceptions. Firstly, where the disconnecting means for a motor is located some distance from the motor and the motor is started by a remote control device, a separate disconnecting means shall be provided at the motor. Secondly, where the motor disconnecting means is not within sight of the motor shall be marked with the location of the disconnecting means. Section 430.131 deals with lockout/tagout. It specifies that if the disconnecting means is not capable of being locked in the open position, a separate lockout or tagout device shall be provided. Examining these requirements more closely, the need for start/stops at motors when using Programmable Logic Controller logic is not explicitly mandated. The code emphasizes disconnecting means and their ability to be locked out for safety during maintenance or service. The primary concern is ensuring that the motor can be completely de-energized and that this de-energization can be secured to prevent accidental restarts. Now let's delve deeper into each section to understand the underlying principles and practical applications. Section 430.110 focuses on the functionality and location of the disconnecting means. The requirement for interrupting the total current under normal operating conditions ensures that the disconnecting means can safely stop the motor under regular use. The need to interrupt the current in excess of the specified in 430.22 addresses fault conditions, where the current can be significantly higher than normal. The provision for locking the disconnecting means in the open position is crucial for safety. This allows personnel to work on the motor or associated equipment without the risk of the motor being accidentally started. The location of the disconnecting means at the point of motor control makes it readily accessible for operation and maintenance. The exceptions to this requirement recognize situations where the motor is controlled remotely or is not within sight of the disconnecting means. In these cases, additional safeguards are necessary to ensure that the motor can be safely de-energized. For instance, if the motor is started by a remote control device and the disconnecting means is located some distance away, a separate disconnecting means is required at the motor. This provides a local point of de-energization for maintenance or emergency situations. Similarly, if the motor disconnecting means is not within sight of the motor must be marked with the location of the disconnecting means. This helps personnel quickly locate the disconnecting means in case of an emergency. Section 430.131 reinforces the importance of lockout/tagout procedures. If the disconnecting means cannot be locked in the open position, a separate lockout or tagout device must be provided. This ensures that the motor can be safely de-energized even if the disconnecting means lacks a locking mechanism. Lockout/tagout procedures are essential for preventing accidental energization of equipment during maintenance or repair. They involve physically isolating the equipment from its energy source and attaching a lock or tag to the disconnecting means to indicate that it should not be operated. The 1999 National Electrical Code, while superseded by more recent editions, still provides a solid foundation for electrical safety. However, it's crucial to be aware of any local amendments or interpretations that may apply. In the context of Programmable Logic Controller logic, the National Electrical Code does not explicitly mandate start/stops at the motor itself. The focus is on providing a reliable and lockable disconnecting means. The Programmable Logic Controller logic can be designed to control the motor in various ways, but the disconnecting means remains the primary safety mechanism for de-energizing the motor. Therefore, when designing a motor control system with Programmable Logic Controller logic, it's essential to ensure that the disconnecting means meets the requirements of Article 430 of the National Electrical Code. This includes the ability to interrupt the total current, the capacity to be locked in the open position, and the appropriate location or marking. Additionally, lockout/tagout procedures should be implemented to prevent accidental energization during maintenance or repair. In summary, while the National Electrical Code does not specifically require start/stops at the motor when using Programmable Logic Controller logic, it does mandate a reliable, unlockable disconnecting means that meets the requirements of Article 430. By adhering to these requirements, you can ensure the safety of personnel and prevent accidents in motor control systems. It is always important to consult the latest edition of the National Electrical Code and any applicable local amendments for the most up-to-date information. Let's explore some practical scenarios to illustrate how these National Electrical Code requirements apply in real-world situations. Firstly, consider a motor control center in a manufacturing plant. Each motor in the control center is controlled by a programmable logic controller, which manages the start, stop, and speed of the motor based on process requirements. According to Section 430.110, each motor circuit must have a disconnecting means that can interrupt the total current under normal operating conditions and under fault conditions, as specified in 430.22a. This disconnecting means is typically a circuit breaker or a fuse disconnect switch located in the motor control center. The disconnecting means must also be capable of being locked in the open position. This is crucial for maintenance personnel who need to work on the motor or its associated equipment. While locking the disconnecting means in the open position, they can ensure that the motor cannot be accidentally started while they are working on it. Now, let's consider a situation where the motor is located some distance from the motor control center and is started by a remote control device. In this case, Section 430.110 requires a separate disconnecting means to be provided at the motor. This local disconnecting means allows personnel to de-energize the motor without having to travel to the motor control center. This is particularly important in emergency situations or when performing routine maintenance on the motor. Finally, let's consider a situation where the motor disconnecting means is not within sight of the motor. In this case, Section 430.110 requires the motor to be marked with the location of the disconnecting means. This helps personnel quickly locate the disconnecting means in case of an emergency or when performing maintenance. Section 430.131 regarding lockout/tagout is also critical in these scenarios. If the disconnecting means is not capable of being locked in the open position, a separate lockout or tagout device must be provided. This could be a hasp that allows multiple locks to be attached, ensuring that the motor cannot be energized until all personnel have removed their locks. The 1999 National Electrical Code, while still relevant, has been updated in subsequent editions. Some key changes and clarifications in later editions include a greater emphasis on arc flash protection and more detailed requirements for motor protection. While the fundamental principles remain the same, it's essential to consult the latest edition of the National Electrical Code for the most up-to-date information. In addition to the National Electrical Code, other standards and regulations may apply to motor control systems. These may include occupational safety and health administration regulations, as well as industry-specific standards. It's important to be aware of all applicable requirements and to ensure that the motor control system is designed and installed in accordance with these standards. In conclusion, the National Electrical Code provides a comprehensive set of requirements for motor control systems. While it does not explicitly mandate start/stops at the motor when using Programmable Logic Controller logic, it does emphasize the importance of a reliable and lockable disconnecting means. By adhering to these requirements and implementing proper lockout/tagout procedures, you can ensure the safety of personnel and prevent accidents in motor control systems. And always consult with qualified electrical professionals when designing or installing motor control systems to ensure compliance with all applicable codes and standards. Furthermore, it's important to consider the specific application and environment in which the motor will be used. For example, in hazardous locations, additional requirements may apply to prevent explosions or fires. Similarly, in corrosive environments, special materials and construction methods may be required to protect the motor and control system from damage. The design of the programmable logic controller logic itself can also impact the safety and reliability of the motor control system. The programmable logic controller should be programmed to provide proper motor protection, including overcurrent protection, undervoltage protection, and overload protection. It should also be designed to prevent accidental starts and to provide a safe shutdown sequence in the event of a fault. Regular inspection and maintenance of the motor control system are also essential for ensuring its continued safe and reliable operation. This includes inspecting the disconnecting means, testing the lockout/tagout procedures, and verifying the proper operation of the programmable logic controller logic. Any deficiencies should be promptly corrected to prevent accidents or equipment failures. In summary, the National Electrical Code provides a framework for safe motor control systems, but it's up to the designer and installer to ensure that the system meets all applicable requirements and is appropriate for the specific application and environment. By paying attention to detail and following best practices, you can create a motor control system that is both safe and efficient. Let us consider the practical implications of these codes on programmable logic controller systems and motor control centers. Firstly, when integrating programmable logic controllers into motor control circuits, engineers often design sophisticated control schemes that can automatically start, stop, and modulate motor speeds based on sensor inputs and process demands. Despite this automation, the National Electrical Code mandates that a readily accessible disconnecting means must be present at or near the motor location. This means even if a programmable logic controller can remotely shut down a motor, a physical disconnect switch or circuit breaker lockable in the off position must be installed. Secondly, Article 430 emphasizes the importance of motor overload protection. Programmable logic controllers can be programmed to monitor motor current and temperature using sensors. If an overload condition is detected, the programmable logic controller can automatically shut down the motor to prevent damage. However, the National Electrical Code also requires a separate hardwired overload protection device, such as a thermal overload relay, to provide a backup in case of programmable logic controller failure. Thirdly, the National Electrical Code requires proper grounding and bonding of motor circuits to minimize the risk of electrical shock. Programmable logic controllers and other electronic components must be properly grounded to ensure a safe and reliable system. The grounding system must comply with Article 250 of the National Electrical Code, which specifies the requirements for grounding and bonding electrical systems. Fourthly, the National Electrical Code addresses the use of variable frequency drives, which are often used with programmable logic controllers to control motor speed. Article 430 provides specific requirements for the installation and wiring of variable frequency drives, including the need for proper filtering and shielding to minimize electromagnetic interference. These interferences can disrupt programmable logic controller operations and cause communication errors. Fifthly, consider emergency stop systems. In many industrial applications, emergency stop buttons are strategically placed to quickly shut down motors in the event of an emergency. The National Electrical Code requires that these emergency stop circuits be designed to fail safe, meaning that a failure in the control circuit will cause the motor to shut down. Programmable logic controllers can be integrated into emergency stop systems, but the National Electrical Code requires that the programmable logic controller be designed to meet the fail-safe requirements. Sixthly, consider maintenance and troubleshooting. The National Electrical Code requires that motor control equipment be accessible for maintenance and troubleshooting. This includes providing adequate working space around the equipment and ensuring that the equipment can be easily disconnected from the power source. Programmable logic controllers can simplify maintenance and troubleshooting by providing diagnostic information and remote monitoring capabilities, but the physical accessibility of the equipment remains essential. Seventhly, consider documentation. The National Electrical Code requires that electrical systems be properly documented, including wiring diagrams, equipment specifications, and operating procedures. Programmable logic controller programs should be well documented, with clear comments and descriptions of the control logic. Proper documentation is essential for safe and efficient operation of the motor control system. In summary, The National Electrical Code provides a comprehensive set of requirements for motor control systems that integrate programmable logic controllers. By understanding and complying with these requirements, engineers can design safe, reliable, and efficient motor control systems that meet the needs of industrial applications. Remember that electrical codes often undergo revisions. It's important to reference the latest edition and any local amendments to guarantee compliance. Also, always consult with licensed electrical engineers and certified electricians when designing or modifying electrical systems. Their expertise is crucial for guaranteeing safety and adherence to code regulations. The National Electrical Code isn't just a set of rules, it's a guideline for building safe, reliable electrical systems that protect people and property. By understanding the code and applying it diligently, we can create a safer world for everyone.